Relative to a fixed origin O, the points A and B are such that O to A is minus 3, 2, 7. O to B is 3 minus 1p, where p is a constant. The points C and D are such that B to C is 0, 6, minus 7, and A to D is 2, 5, minus 4. Part A, find the position vector of point D. So point D is going to be the same as, well, I know what O to A is, and I know what A to D is. So if I go from O to A and then add A to D, that's going to be the same as me going just from O to D. So going from the origin to point A is the vector minus 3, 2, 7, and then going from the point A to the point D is vector 2, 5, minus 4. So adding them together is the same as going from the origin to point D, which is minus 1, 7, 3. We're then told that A, B, C, D is a trapezium. Find the value of P. Right, so let me just draw a little sketch of this thing then. A, B, C, D. So A, B, C, D. So this is just a random trapezium I'm drawing here. In real life, the trapezium won't look like this. But that's fine. It doesn't matter how accurate this sketch is. The point is that with a trapezium, two opposite sides are going to be parallel. So let me try and figure out what the vector A to B is, and then what the vector D to C is, and then compare. It might not be A to B and D to C, it might be A, D, and C, and B, C that are parallel. In fact, I know it's not that. Comparing these two vectors, I know AD and BC are not parallel, just looking at those vectors. This vector here is definitely not parallel to this vector here. It's not a multiple. So actually my diagram is going to be more, it is going to be, well, not correct, it's obviously still inaccurate, but I do know it is that the AB and the DC are the parallel sides, if it's a trapezium. Right, so let's do A to B first of all. Let's figure out what that vector is. So A to B, well, I could go from A to O, the origin, and then from O to B. Now I know what O to A is, so A to O is going to be the negative of that. And I know what O to B is. So adding those together, we get 6 minus 3 and P minus 7. So that's the vector A to B. Let's now do D to C. So for D to C, I can go from D to O and then O to C. Now D to O, well, I worked out in part A of the question, I worked out that this was O to D, the position vector of point D. So D to O is the negative of that. And O to C, I've not got that written down anywhere yet, but I can work it out pretty easily. O to C is going to be the same as going from O to B plus B to C, because I do know both of those. Excuse me. O to B, I was told here. And B to C, I know here. So that's going to be 3, 5, p minus 7. So adding those together then for the vector d to c, we get 4 minus 2 p minus 10. Right, we have d to c. So this is d to c. This is a to b. And they should be parallel. So let's compare them really carefully. In fact, it might help if I can. There we go. Let's move this down here. Let's compare. They have to be parallel. And looking at the x components, I can see that the 6 is 1.5 times bigger than the 4. And the minus 3, I can see, is 1.5 times bigger than the minus 2. So that means that comparing the z components then, the p minus 7 has to be 1.5 times the p minus 10. Which means that p minus 7 is 1.5p minus 15. So 0.5p is equal to 15 minus 7, so 8. So p is going to need to be 16.